Alright, so we're going to be studying lesson 4, which is over chemical properties and changes. This will be kind of the counterpoint to the physical properties and changes that we were talking about earlier in this chapter. So the vocab, we have chemical property is a characteristic of matter that can be observed as it changes to a different type of matter. And we will get into more of what these are going to be when we get further into the lesson. Chemical change is a change in matter in which the substance that makes up the matter change into other substances with new physical and chemical properties. The last one is going to be concentration. That's the amount of substance in a certain area. So you have to specify the area and then tell us how much substance is in that area. Chemical properties are caused by bonds breaking between molecules and rearranging into new molecules. This allows things to burn, rust, decompose. These are all different types of chemical reactions. There are 5. We're not going to go into what the 5 are, but know that they are caused by the breaking of bonds and forming of new bonds between molecules. Alright, so comparing properties. All matter can be distinguished by both properties, or all matter can be distinguished by both chemical and physical properties. So we've talked about physical properties already, whether it be solubility or conductivity or density. In this case, we're talking about more than that, and we're talking about chemical properties. Wood has a different set of properties than gold, right? Has a different set of mass, a different set of density. It melts at a different point, melts at a different temperature than gold. All this stuff is very common sense, and hopefully we understand that. Chemical changes. When matter undergoes a chemical change, it's actually changing the type of matter that it is. So at the very, very smallest level, you have elements. And those elements don't exactly change, but the way that they're arranged gets changed. And we'll talk about that more in class when we go through the notes, but that's an interesting thing to try to kind of grasp. Not so much the elements themselves don't change, but the way they're arranged with other elements changes. That means that they no longer have the same properties. So once you change that arrangement, the properties aren't the same. We talked about a little bit in class the huge difference between H2O and H2O2. One's water, very, very drinkable, necessity for life. The other one's hydrogen peroxide, which, I mean, we've all put it on our skin before and it'll make you bubble, so I wouldn't want to be drinking that very often. Alright, so there are a few different signs of chemical change. The formation of bubbles, right? We just talked about that with hydrogen peroxide. We can also picture this as Alka-Seltzer, those bonds breaking, making bubbles. Baking soda and vinegar is another good example of this. The energy change, which would be fireworks and fire. Change in odor, right? When those chemicals start to rearrange, that rotting food gets a lot stinkier. And lastly, change in color. Leaves change color. We can see that rust is a really, really prevalent one. It's an easy one to point to. That's actually a change of iron and oxygen into iron oxide. And then copper is the same kind of thing. Like you might see the Statue of Liberty is copper that's essentially being oxidized, which is the copper equivalent of being rusted. So explaining chemical reactions. Note that we're going to abbreviate reactions RXN like we have before. Reactions occur because molecules collide. So they're always constantly bumping into each other. And hopefully after last lesson you kind of started to put that together, that if the things bump into each other and the faster they go, the more they bump into each other. So that's the next point. The more they collide, the faster they, in this case, is referring to the chemical reactions. The faster the chemical reactions occur. So when bonds break and molecules rearrange to form new molecules, but the same amount of each element is present. It's just in a different order. So this is our conservation of mass. If we have a closed system, which is something that we're going to be talking about really, really soon, that means that nothing is leaving the area. So I have a nail with oxygen, so I have iron and oxygen, and I measure that, I weigh it, and I mass it out, and then I wait until the nail is all rust, which is iron oxide, but we didn't let anything leave our system. then we know, because of the law of conservation of mass, that it isn't going to be a different weight. It's going to have the same exact mass. And quick point, I keep using those words interchangeably. That's not correct of me. The mass will stay the same. The weight of the nail might actually change, or the weight of the air might actually change, but the mass inside the closed system will stay the same. Alright, so using chemical formulas. We've talked about this stuff briefly, mostly with respect to cellular respiration and photosynthesis. To understand a chemical reaction, we write it out as a chemical equation. So, our chemical reaction says that 2H2 plus O2 goes to 2H2O. So in this case, H stands for hydrogen, O stands for oxygen. On our left side, we've talked about this before, on our left side we have the reactants. That's what's actually undergoing the reaction. On the right side, we have our products. The plus is there so that we know that these things are separated, right? Because there's a huge difference between hydrogen and oxygen than there is between hydrogen, or in this case, H2O, hydrogen, and oxygen bonded together. That means they're bonded together. This means they're not bonded together. So that plus tells us that they're not bonded together. The last thing, these 2's out front, just like in math, if we have 2x, it's called a coefficient. Here we have 2H2O, so that means we have 2 hydrogen 2 molecules. Alright, rate of chemical reactions. We have the first one. These are all things that affect the rate of chemical reactions. Temperature, the higher temps means the faster the particle movement. Therefore, the particles collide more and react more. So you have to think about it as when we start heating things up, things start to move around a lot more quickly, and because they start to move around a lot quicker, they start to bounce into each other more. And when that hitting and bouncing occurs, there's more reactions. I will say that it helps me when we're going through this list to visualize whatever reaction you might want it to be. I think that iron and oxygen making rust, or iron oxide, is a really easy one to picture. So if you put if you put iron in a container with oxygen and then turn up the heat, it would actually rust faster because temperature affects the rate of reaction. So the higher the temperature, the quicker the reaction. Alright, our next one's going to be concentration. The more atoms you have in an area, the higher chance to collide, thus faster reactions. This makes sense, right? The more you have in one area, so if I packed 10 of you guys into one room, you're going to bounce around and hit each other a lot more than just 5 of you guys in the same room. Our last one, okay, so going back to concentration. So the higher the concentration, the faster the rate of reaction. Lower the concentration, the lower the rate of reaction. And surface area. The more exposed surface area, the faster the reaction. That one's a little harder to visualize, and we have a picture coming up right here. So, if our little red dots are hydrogen, and then whatever we want to call our green dots, we can see that our red dots are having a lot harder time getting to the things in the middle. So our surface area is pretty low considering the amount that we have here. If we look down here, our example, we have a lot more surface area, right? If we wanted to, we could count up each of these little dots that's exposed to the outside and say that accounts for the surface area. I mean, I can tell you that this up here has a lot less surface area than this down here. But you can see that because it has more surface area down here, it's going to react quicker. These red dots are going to be able to hit in more different spots.